So let's go. Today I will talk about optimistic concurrence. Being optimistic about concurrence in SQL Server. Who I am? My name is Dennis. I'm a Microsoft Certified Trainer. I deliver Microsoft trainings. I'm a Microsoft Certified Solution Expert in Data and BI. And I'm the user group leader of Data Platform User Group, Malta Data Platform User Group. And who we are? The Microsoft Malta Data Platform User Group. The URL maltapass.pass.org, created by the community to the community. The user group is a set of people that works to deliver technical information, deliver technical content, and sessions like this one that I'm delivering today. We have a Facebook page and a group. We have a meetup group, WhatsApp group. The address of all these groups are on our website, malta.pass.org. So we can visit our website and register for the meetup, for the Facebook group, and we can keep in touch. Data Platform User Group is a PASS official group. What's PASS? It's an international organization that gives support for user groups all around the world, especially SQL Server user groups all around the world. Our website, for example, is hosted by PASS. Our website is a template that PASS gave to us, so we built our website over this template. PASS is supported by Microsoft and many other sponsors. Okay, what will we see today? What our subject today? Pessimistic versus optimistic concurrence. What's the difference? Optimistic isolation levels. General behavior of these isolation levels. General behavior of these isolation levels, and we will see demonstrations of these isolation levels. There are two different isolation levels for optimistic concurrence. This is the missing part from our last meeting. Our last meeting was an in-person meeting here in Loja, and we had no time to complete the meeting talking about optimistic concurrence. So today I will complete this subject about isolation levels and locks, talking about optimistic concurrence. So, pessimistic versus optimistic concurrence. What's the difference? On pessimistic concurrence, we are expecting the concurrence. We expect the concurrence to happen. And we avoid the concurrence using locks. We lock the records to avoid the concurrence. The locks affect the scalability of the solution. Our hardware, our solution will accept a smaller amount of concurrence access on the solution. And for a web environment, this is not good. Optimistic concurrence, on the other way, expects that concurrence will not happen. Using optimistic concurrence, we don't expect to have concurrence. What I mean, how is this possible? Not expect concurrence. This is possible by the business rules. We don't expect two people to update the same record at the same time. We are not expecting a concurrence on this level. So, the optimistic concurrence checks for concurrence before an update. If the concurrence happens, if two people have tried to update a record at the same time, we get an error. This is a big difference between pessimistic and optimistic. Pessimistic is expecting the concurrence. So if a concurrence happens, the system gets more slow. The system will need to wait for the concurrence to happen. The first person updates the record, then the second person updates the record. But it will work. We will not get an error. With the optimistic concurrence, the concurrence is not expected. This is used for systems where the business rules usually avoid the concurrence. It would be impossible for one person to be updating the same record at the same time. For example, a system for telemarketing, for example, each person will be looking the record of one customer, talking to the customer on the phone and managing the record of one customer. It would be impossible for two different people be using the record of the same customer. The same customer can't be on the phone with two different persons. So, if our business rules can avoid the concurrence, the optimistic concurrence, optimistic isolation levels may be a good choice. What are the optimistic isolation levels that we have? We have the snapshot isolation level. This isolation level requires code change to be used. Our application needs to be designed to use the snapshot isolation level. We plan our application for it. This isolation level avoids the usual concurrence problems that I demonstrated on our last meeting. For example, phantom records, non-repeatable reads, concurrence problems that can happen when many people are using the system at the same time. This isolation level avoids these problems. However, there is a higher chance of error on a bad code. I will explain more about this later. What I mean about bad code? I mean that sometimes our code is not perfect. Our code has errors, has some bugs. But sometimes a bug on our code may only appear on a very specific situation that never happens in production. Never happens in production. So the bug is there, but the code is running and working, and we never get that bug. We never see that bug happening. It's almost impossible for it to happen. However, when we move our concurrence system from a pessimistic concurrence system to an optimistic concurrence system, this kind of bad code that is in production but never causes a problem may cause a problem. If we have this kind of bad code, we may get problems. The snapshot isolation level has a higher chance to give problems with this kind of bad code. However, we have a different type of optimistic isolation level called read committed snapshot isolation level, RCSI. This second isolation level doesn't require code change to be used. This is very, very interesting. We can get an existing application that's already in production and change some configurations for this application to use read committed snapshot isolation level. It will be automatic. We don't need to change anything on the code. We can only reconfigure, change the application configuration, and it will work. However, this isolation level doesn't avoid all the usual concurrence problems. All the usual concurrence problems that I demonstrated on our previous meeting, phantoms, non-repeatable reads, can still happen with this isolation level. The snapshot isolation level avoids all of them. The read committed snapshot isolation level doesn't avoid all of them. But there is a smaller chance of error on a bad code. The snapshot isolation level has a higher chance of error on a bad code. The read committed snapshot has a smaller chance. But it still has a chance that an error will happen. An error that is on production but never happened before can start to happen. Let's talk more about this. We talk more about this and I'll show some demonstrations. The general behavior of these isolation levels, how they behave. A version of all the records used by the transaction is stored in TempDB during the transaction. So, when we start using optimistic concurrence, we increase our use of TempDB. The TempDB will be a lot more used. Our use of TempDB will be increased. We need to take care about this. And what this means, a version of all the records is stored on TempDB, how this happens? Well, to allow selects to be executed with no blocking, we will have no blocking on the selects. All the records are versioned on TempDB. So our selects will be reading a version of the records, the last version available on TempDB. If two transactions try to update the same record, the second transaction will fail, get an error. This is a very different behavior than on pessimistic concurrence. If this happens on pessimistic concurrence, the second transaction will not get an error. We'll wait the first transaction to finish and then update the record. But using optimistic concurrence, we get an error. If two transactions try to update the same record, we get an error. The second one will get an error. This is due to the versioning system. The versioning system on TempDB. Why? Well, the second one that's trying to update the record is not seeing the correct version of the record. The second one is seeing an old version on TempDB, but the record was updated by the first transaction. So, due to that, the optimistic concurrency isolations doesn't allow this kind of concurrency. The second transaction will get an error. So, optimistic concurrency are very good for scenarios where it's not usual to have a concurrence on the same record. For scenarios where the business rules will avoid the concurrence on the same record. Two employees of the company will never try to update the same record because the business rules. This is a good scenario for optimistic concurrence. If this kind of simultaneous update will happen, this will not be a good scenario for optimistic concurrence because our application would need to deal with this kind of error. This kind of error will get very usual, and this will not be a good interface for the user. There are some difference between the snapshot isolation and the RCSI isolation. On the snapshot isolation level, when we have two transactions happening at the same time, and two transactions, A and B, happening at the same time. Transaction A commits the information, finish and commits the information. Transaction B is still executing. Using the snapshot isolation level, transaction B can't see the information committed by transaction A because there is a consistency according to the beginning of the transaction B. No change after the beginning of the transaction B will be visible during the transaction. This behavior on the snapshot isolation level ensures that we will not get the usual concurrence problems that I demonstrated on our previous meeting. The phantoms, the non-repeatable reads, no one of that problems will happen using the snapshot isolation level. Using RCSI, this doesn't happen. In this case, transaction B will be able to see the changes after transaction A is committed. The change will appear in the middle of the transaction B. In this case, RCSI can still cause problems like non-repeatable reads, like phantoms that we talked on the previous meeting. These problems can still happen on RCSI. So, when should we use one? When should we use the other one? Well, according to this explanation, snapshot isolation level may seem a good choice, a better choice, a more secure choice. However, these problems that I'm talking about, they exist, and it's not something very usual that we need to care about them. Our transactions are not usually really affected by them. If they are a problem for your kind of system, you should use a snapshot isolation level, but if not, you may have no problem using RCSI. But this is not the main decision choice here. The main decision choice here is the fact that for a snapshot isolation level, your application will need code changes. Your application needs to be planned for the snapshot isolation level because your application will need to set this isolation level on the code. on the code of the application. The RCSI, on the other hand, doesn't need any change on the code of the application. The name of this isolation level means read committed snapshot isolation level. What this means? The default isolation level of the server, of SQL Server, is read committed. We saw how this works on our previous meeting. Read committed is the default isolation level. When we enable read committed snapshot isolation level on a database in SQL Server, the read committed isolation level will be transformed in a snapshot isolation. Not exactly the snapshot isolation level, will be transformed on a isolation level based on snapshots. That's what RCSI is. The read committed isolation transformed on a snapshot isolation automatically by the database configuration. In this case, we can just change the configuration of an existing application already in production, and that application will work with RCSI. Will work very well with RCSI. What the benefit? Well, these are optimistic isolation levels. Optimistic isolation levels, I haven't emphasized this enough yet. Optimistic isolation levels doesn't block any query, any select statement. We get no blockings for select statements on optimistic isolation levels. Doesn't care if it's snapshot or RCSI. This is the behavior of both. We get no blocking on all selects. This is very good. Usually, many developers use the no lock hint to get this behavior, but I proved to you on our last meeting that the no lock hint can cause many problems for us. Many problems. The no lock hint will read false records, fake information from the database. On the other hand, these isolation levels, the optimistic isolation levels, will have the benefit of having no blocking without the problems of the no lock. And this is very good. Let's talk more about the snapshot isolation level, known as the isolation level without locks. That's the optimistic isolation levels at all. Each query creates a static snapshot in TempDB database during the transaction. Updates still create locks, but the update locks will not block selects. Deletes and updates are not seen across transactions. The example I explained it. Two transactions A and B running during the same time. Even if transaction A is committed, transaction B will not see the deletes and updates made by transaction A because both were running at the same time. The benefits: reduce lock contention, improving scalability. The problems: different concurrence problems. We get an error if we have concurrence, for example, and intensive use of TempDB. Problems. What kind of problems we can get on using snapshot isolation level? Concurrency conflicts can happen and can generate an error. Our application will need to deal with this kind of error. But as I explained, if our business rules avoid concurrence, we will not have many problems with this. The letter records are still present in the concurrent transactions. If a record is deleted on one transaction, the other transactions running at the same time will still see that record. There is an error margin in some transactions, a margin for errors that will increase. That's the situation I explained about a hidden bug present in production but never happened before. It can appear with the snapshot isolation level or with RCSI. In practice, what this means? In practice, someone needs to get the responsibility for this kind of problem if it happens. But it's impossible to predict for an existing system if an error like this will happen. So most time people just risk. Just enable RCSI, for example, and take the risk. Let's see a demonstration. First with the snapshot isolation level. I will open some script files. I have 5 script files that I will execute together. I use Northwind. The snapshot isolation level makes an intensive use of the TempDB database, so it needs to be enabled by the server administrator. We can check if it's enabled or not, checking the sysdatabase system table, DMV. Here you can see on which database the snapshot isolation is enabled and on which one it's not. There are 2 configurations, one for snapshot isolation level and the other to enable with commented snapshot. Now I will enable the snapshot isolation level for Northwind. I can query the DMV called dm version store. This is the version store for Pessimistic concurrence isolations, but there is nothing there yet. Let's start something. I will move from script A to script B. Here on script B, I will start an update. Okay, I started an update on one customer record. One thing is very important here. This transaction that started the update is not using a snapshot isolation level. to use snapshot isolation level, I need to set the isolation level. I haven't, so this transaction is not using snapshot isolation level, is using read committed. But the snapshot isolation level is enabled on the database. Only due to the fact that it's enabled, all the activity on the database change. That update, I'll add created a version for the record on the version store. We already have a version for the record on the version store. Here we can see we have a lock. It's an update on a read committed transaction. We have a lock of the record. And the record is on version store. Now I will move to script C. And try to select customers. Once again, this transaction is not using snapshot isolation. It's a read committed snapshot. It's a read committed isolation level. And it's blocked. Of course, there is a lock. The other transaction is blocked. This is the regular behavior on read committed isolation level. Let's get back. So we have a blocking. We can see here a shared lock. A shared lock waiting to be inserted. Here doesn't show this part of the screen. Here we can see a shared lock waiting to be inserted on the record. We have a blocking, but I'm not using snapshot isolation yet. Now on script D, in this transaction I'm using the no lock, the terrible no lock that I already demonstrated that you should never use. What happens now? No lock is not blocked. This is expected. The no lock reads uncommitted information. Let's check again the update on B. I'm updating the contact name of the record ALFKI to Maria. So on the script D, it's updated to Maria. I'm seeing an uncommitted information. Okay. And let's go to script E. Now I will use a snapshot isolation level transaction. Use Northwind and let's set the isolation level, snapshot, and make a select on customers. First, my select is not blocked. I get no block on the select because I'm using a snapshot isolation. But what's the difference between this select and the select with the no lock? Look at the record. On this select, I'm reading the old information on the record. I'm not reading the updated information on the record. I'm reading the old information on the record because snapshot isolation level use the version store to read the records. It's using the tempdb to read the records. When the update happened on the database, a version of the record were created on the tempdb. And the transaction using isolation snapshot is reading from tempdb. Let's compare. On script D, I used no lock and I got an information that's not commented yet. On script E, with the snapshot isolation, I got the correct information really commented on the database server. So, with this example, we can notice snapshot isolation level is much better than no lock. Instead of using no lock, we can use snapshot isolation or RCSI, which we will see a demonstration in some minutes. Let's get back to script A. Now I will commit transaction B. Commit transaction. In this situation, the record is still in the version store. What this means? The transaction that inserted the record on the version store, the transaction on the script B that created the version on the version store finished, but the record is still on version store. Why? Because there are still transactions using this record. When no more transaction is using this record, the record will be automatically removed from version store. But while we have a single transaction using this record, the record will be on the version store. Let's do a new select on script E. The same select. The transaction on the script B, the update, is commented already, but there is a consistency according to the beginning of this transaction. This transaction have read Maria Anders from the record. This information will not change during the transaction. We will not see different information during the execution of this transaction. That's why the record is still on the version store to ensure this consistency. Okay, so I illustrated that the snapshot isolation level transaction is always reading the same information, even after the information is changed and committed, but it was changed during the transaction. So there is a consistency with the beginning of the transaction. The information will not change during the transaction. Now, let's try an update. I'm trying to update a different record. It's a customer record, but it's a different record from a different customer. I'm totally able to update the record. Let's come back here. The update on the snapshot isolation level transaction still creates a lock. I explained it. Updates still create lock. So let's return to the script C. Here I have a regular transaction that's not using snapshot isolation. If I make a select on this transaction is blocked by the lock on the update created on the snapshot isolation transaction. Let's get back to script D. I'll create a rollback and create a new transaction that's a snapshot isolation level transaction. Another snapshot isolation level transaction is not blocked by the update. There is no blocking on selects on a snapshot isolation level. The update creates a block that will affect other updates or will affect select on other kinds of transactions of other isolation levels. Transactions using snapshot isolation level are not blocked on the select. They are reading a version of the record from the version store in TempDB. Now on transaction D, on script D, I have this other transaction. I try to execute this update. You may notice I'm trying to update the same record than the other transaction. It's blocked. The first result is the blocking. I'm trying to update the same record. There is a lock on this record, so I get a blocking. But not only this. Let's return to script E. I started this transaction many selects ago, and the record ALFKKI was updated. If I try to update this record now, I'll get an error because I'm not seeing the most recent version of the record. The snapshot isolation level doesn't allow me to update a record if I'm not seeing the most recent version of the record. Someone else updated the record before me. So I get an error and my transaction is aborted. I get a conflict on the updates. Okay, on D, since that transaction was aborted, this update was completed. On D, let's return to E and execute a new update. I have a new transaction with an update trying to update the same record than the other script. Again, I get blocked. The script D is blocking this. If I commit the script D, this transaction is committed, but on E, besides the blocking, that is the first reaction, the second reaction is the conflict. I'm trying to update a record that is already updated by another transaction, so I get a conflict in my transaction is aborted. Now, if I check the version store is empty. All the transactions have been completed. Let's execute this to return everything to the starting point. Okay. Any questions? Nope. Okay. Let's continue on the explanation. I talked about bad code. Bad codes, codes with bugs that may be hidden in production. How is this possible? Look at this code. This transaction is reading the stock of the product, make some decisions, and then updating the stock of the product. This is not a good code. This is a bad code. Why? Because the reading of the stock is not blocking the record. The reading of the stock is reading and proceeding. This creates an error margin inside the code. If any other simultaneous transaction reads the stock between the select and the update statement, between these statements, this will create an error and the stock will be wrong. If another concurrent transaction reads between this time interval, the stock will be wrong. This is a problem. But sometimes this interval is so small that it never happens. So this is a bug. It could happen. But sometimes using the pessimistic concurrence, this interval is so small that it never happens. It never happens. However, when we change this to optimistic concurrence, our transactions will be reading a version of the record from the version store. In this situation, the error margin is bigger because this change will only be available after the commit of the transaction. After the commit of the transaction, the change will be available. Before the commit of the transaction, many other concurrent transactions will be reading the stock and getting a wrong value for the stock. So the time margin for the bug to happen increase due to the change from pessimistic to optimistic concurrence. So this is the example of a bad code that can be present in a production system, and this bug could never happen before because the time margin was very small. And if you change from pessimistic concurrence to optimistic concurrence, then you will be increasing the time margin for the bug to appear. And you may get errors due to that. And as I said before, most people just take the risk. It's very difficult to know inside the production system where you may have a situation like this and your code may be already wrong and would result on this situation, an increased margin for errors. It's very difficult to identify this. Let's talk now about the read committed snapshot isolation level, RCSI. Enabled on the database level. Our advantage from snapshot isolation and lower danger can be applied to existing applications without code changes. I love RCSI. I already use RCSI on a production environment. In fact, I used it to save a production environment. The production environment was not supporting the amount of people using the server on the same time. The processor was reaching 100%. The application were getting a lot of blocks, a lot of locks at the same time. It was impossible to use the system on some days. So I enabled RCSI and the result was immediate. The amount of use of processors dropped, the amount of locks disappeared, and people were able to use the system. It can save the production system. So to enable RCSI, we need to set the database to single user and then enable snapshot isolation level on the database. To disable, we disable the read committed snapshot. Sorry, this first one to enable is wrong. We need to enable read committed snapshot and disable read committed snapshot. And we need to set the database to single user to do this. The database needs to be set to single user. We can check if it's enabled or not with a select query on the sys database. Let's see a demonstration. I will use AdventureWorks. I need to set allow isolation level, allow snapshot isolation. Check what's enabled or not. AdventureWorks CTP3. It's allowing isolation snapshot, but RCSI is not enabled. For our example, let's check the modifier date on the table shift. All the dates are the same. It's this date. The isolation level will be read committed, and the idea is that the read committed which is the full isolation level for our transactions or database, will be transformed on a snapshot isolation. Now I will set read commit snapshot on with rollback immediate. I'm getting blocked. There is some other connection using the same database. Probably it's another SSMS connection, maybe from the Object Explorer using the same database, or maybe I have another window here. Failed and can conceal it. I need to set a single user to ensure that this doesn't happen. The instruction, let me copy that. I'm lazy. Let's put the database as single user. Adventure Works 2016 CTP3. Let's see the activity. I opened so many windows that maybe some other window is using it. No, I don't think so. Now it worked, it's on single user. Now I enable the read commit snapshot and I set to multi-user again. Okay. So let's start the first session. Begin transaction. I will update human resource shift set modifier data equal get date. I'm updating the date of all records of human resource shift. But you may note human resources shift. I'm on the correct database, right? Right. Let me check what happened. I'm on the correct database. Human resources shift. Let's copy the table name if I made some mistake. Okay, updated. You may notice I haven't set the isolation level. In fact, in the opposite, set the isolation level for read committed. But what this configuration does is exactly to transform the read committed on a snapshot isolation. Let's check the other scripts. Let's check the script C and the version store. Here, the update created 3 records on the version store. I have 3 records on that table. So, have 3 records created on the version store. Let's check on B. I'm using read committed. My transaction with the update is still executing, but now I will execute a select and I get the old date. That's the point. Using read committed, this transaction should be blocked. But this transaction is not using read committed anymore. The read committed is being transformed on a snapshot isolation. This select is coming from the version store, from tempdb on the version store. And I get no blocking for this select. That's very good. Now let's commit. I just committed the update. This transaction on B was already being executed. On the snapshot isolation level, we saw the information would not change during the transaction. But on the RCSI, the information changed during the transaction. This is the non-repeatable read problem that I illustrated on our first meeting. I tried to read the same information twice during the same transaction. The information comes different. So the snapshot isolation avoids this kind of problem, but the RCSI doesn't avoid this kind of problem. Is this really a big problem? RCSI still can allow us to improve our scalability of production applications without any code change, only changing the configuration, enabling RCSI on the database level. And this kind of problem, or non-repeatable read phantoms, are not very usual. This happens, but it's not very usual that we have transactions affected, really affected by them. Let's check the version store on C. Again, the transaction is still being executed on B. The transaction hasn't finished, but let's check the version store, and we have no more records on the version store. Using the snapshot isolation level, the records were there, because even with the transaction that created the record finished, other transactions were using that record. Using RCSI, this doesn't happen. That's a big difference between RCSI and snapshot isolation level. And this is the difference that makes snapshot isolation level more secure about concurrence, while RCSI still can present to us some concurrence problems. Let's return to B. Transaction B. Now I will execute an update on B, to update to get date. I executed the update in the middle of the transaction. Let's start another transaction here on A, begin transaction, and execute the update on the same records. I'm executing the update on the same records. In this case, I get a blocking between both updates. Let's come to C. I can check the blocking. I see the block on the records. Now on B, I will commit the transaction. I will not go back. I will commit the transaction. And the A is also committed. Have you noticed the difference? On the snapshot isolation level, A would never be committed because B committed before. So A would get a concurrence error. On RCSI, this doesn't happen. A is committed. RCSI can create some conflict, but still it can save a production application. Let's go back. Then I can disable everything. Questions? Today we saw snapshot isolation level, RCSI. They are the two isolation levels, two optimistic concurrence isolation levels. We saw the difference between pessimistic concurrence and optimistic concurrence. How optimistic concurrence can improve our scalability by having no lock on our selects. The lock happens only on updates, not on our selects, by using the version store on tempdb. And we saw difference between snapshot isolation level and RCSI. How snapshot isolation level is much more secure than RCSI, but requires code change on the application. The application needs to be planned for the snapshot isolation level, while the RCSI is only a change on configuration on the server and the application will be using RCSI. Questions? Nope. Okay. So, remembering the link for our website, my personal email, my Twitter. You can always get in touch, send any questions to me. Feel free to send any questions, any comments, and thank you very much for your presence today. Thank you, and see you on our next meeting.